Hello, welcome back to my tech farm. I have two very interesting filaments for this video, and there's the Carbon Fiber ASA versus regular ASA by 3DO. Approximately a month ago I did a review testing some carbon fiber PLAs, and there I got the suggestion from viewers to test this very interesting carbon fiber ASA from the 3DO. And actually it was Sunday afternoon. I contacted them, I sent the email, and in less than an hour I got the answer that they are happy to cooperate with me. But as always, this is not a sponsored video, except that I got these two filaments for free, and I will do that regular testing, so the results are comparable with those which I did in earlier videos. And the results you can download from my website for each video separately, but for my Patreon supporters I am always preparing that summary Excel table, so they can very easily compare these results with those I did earlier or I will do in the future. About print settings, in both cases we have to use the temperature between 230 and 250 degrees Celsius and the bed between 100 and 110 degrees Celsius. And of course with ASA I like to use the enclosure. It will be the passive enclosure, so approximately 45-50 degrees Celsius inside. And since one of them is carbon fiber, I have to use a harder nozzle. And also it is recommended on their website to use at least a 0.6mm nozzle or bigger. Now I have two types actually. One is from stainless steel, which basically I would like to use only for some food save applications. So I will use this one. It is M2 high speed steel from the Micro Swiss. I was in conversation with the CDO and they told me that they are regularly printing on 0.4mm nozzle too, but since it is officially recommended 0.6, that I will use this nozzle for both materials. Not sure about a layer height, probably I print everything with 0.2mm, not 0.3, because if you're not familiar, bigger layer height means bigger chance for the warping. Maybe later I will print something with 0.3mm, but my test subjects will be printed with 0.2. Now let's see what's in the box. A cute surprise. I can see the packaging is not vacuumed, but there is some silica gel inside. ASA is not so sensitive to moisture anyway. And as you can see, we have the same information on this sticker here. Maybe it would be good to add here information that we have to use the harder nozzle and with 0.6mm or bigger. For replacing a nozzle, I need approximately 3 minutes. So first I'm removing the silicone sock and I'm preheating the nozzle to remove any filament inside. And I'm using a bigger open end wrench on the heat block and a smaller one, 7mm, on the nozzle. And then I can insert the new nozzle, and I have to tighten it, but it is important to have this small gap after tightening because the nozzle has to align on a heat break and not on a heat block. And I already mentioned that I will print everything inside the enclosure. This is modified NS3V2 with Micro Swiss direct drive extruder and a Wem PEX sheet, and inside the acrylic enclosure, only I moved the screen outside. And I will try to print first without any adhesives on the bed surface, but if I will have some problems, then I will place some LD lac on it. And first I will start with the regular ASA, because somehow I have the feeling that this will be harder for the printing compared to the carbon fiber version. And my first experience with this filament is that it unrolls too easily, so I have to pay attention to this at least at the beginning of the printing. This is the first layer and it sticks very good, but now I have to completely close this enclosure. The progress is good. This is now the third element of 230 degrees Celsius and there is no sign of the warping so far. The temperature inside the enclosure is 45 degrees Celsius and only 20% relative humidity. Printing is finished a few seconds ago. Just quick check of the bed adhesion. Which is good, but of course I will wait until it cools down and only then I will remove the object. The bed is 40 degrees Celsius. Oh, that was easy. Let's analyze this temperature tower, because I got very similar results on all three temperatures. So the stringing is fine. I have never problem with the stringing with the ABS filament, and also the bridging is very acceptable on all three temperatures. Now the biggest problem here is the overhand. With 0.6 nozzle and 0 part cooling, you don't have enough time to cool down, especially with those bigger overhangs, so this is not acceptable. And probably I print all test objects at once, except those vertical test specimens where I have that smaller cross-section area, 4 by 4 millimeters, and I'm sure with these settings it cannot be printed. So there I have to use at least 10 or 15% part cooling. I decided to give it a try, so I'm printing all test objects at once on 240 degrees Celsius and 50% part cooling. The printing is at 60% and all test objects are perfectly straight so far. And last two objects for the layer adhesion test. This overhang will not be so perfect. I can see the material curls up a little bit. And unfortunately I had to stop the printing because it really curls up too much. So it needs or more cooling, or I had to slow down a little bit here the printing. So these two test objects will be printed again separately, but all other test objects are perfect. And the bed cooled down and it is very easy to remove them from the build surface. And this time it will be finished correctly. I didn't change the part cooling, it is 15% as previously. The only thing I changed here is that I reduced the printing speed on that critical overhang by 20%, and this time it will be finished correctly. And of course I will use the same G-code with the carbon fiber version. And now moving to the carbon fiber version. I noticed that both filaments unroll too easily if there is no tension on the end of the filament. I think this edge could be a little bit bigger. And now printing the temperature tower using the same G-code. The start is good. The progress is good, and that overhang looks much better now, and I will compare them side by side when it's printed. The bed cooled down. And side by side these two temperature towers looks very similar from the aspect of the stringing or from the bridging. The top surface is also over melted in both cases, but the biggest difference we can see in overhangs. So this version with carbon fibers looks better compared to the regular ASA, but this is also far from perfect, so definitely some minimal part cooling is required here. And I will repeat the same test files, so I will print all test objects at once, and those for the vertical test objects I will print separately using the same G-codes. Start is good, this is the first layer. And this is now the fifth layer, and it looks okay so far, and I hope it will stay like that because this will be finished overnight without the supervision. Good morning, and let's see the morning surprise. And it's finished correctly. Printing with the same file. And as I expected, using the same G-code, this printing is nicer because those carbon fibers gives more stability during the printing, and this overhang is also nicer. This is the maximum temperature inside the enclosure, and with this low relative humidity it also keeps the filament dry during the printing. ASA is not too sensitive to moisture, but for example nylon, yes. And I can start the mechanical testing with tensile or pulling test. This test object is printed in horizontal position, 4 by 4 millimeters is the smaller cross-section area, and I'm starting with regular ASA, and I got same values here. The next is the carbon fiber version. And very similar break loads here. If we take a closer look, we can see a small gap on the break point, and this may be the disadvantage of 0.6 nozzle because it cannot fill all those gaps. That's why using 100% infill, I noticed that it's better than the maximum number of the valves. But this is my testing method, so I will not change this. But for mechanical parts, 100% infill is better than maximum number of the perimeters. This I measured in a separate video. Now we can move to the layer adhesion test. These test objects are printed in vertical position, and again 4 by 4 millimeters is the smaller cross-section area, and I'm starting with regular ASA, and very similar values I get here too. The next is the carbon fiber version. And again very similar values here. Everything about 20 kilograms are acceptable from my side. And we can see these cross-section areas side by side. Next test is a 3-point bending test. Here you can see my test setup. These are the weights I will use, and I am using 1.25, 2.5, 5 and 10 kilograms, and I'm measuring not only the initial deformation but after 30 and 60 seconds. In the video I will show you only side-by-side deformations after 30 seconds for ASA and for carbon fiber ASA next to each other. And at the end, a removing of the load. All values I will show you in the results part. Visually I cannot see any permanent deformation on these two test objects. Another shear stress. And I'm starting with ASA. And now carbon fiber version. And for the filling, both are equally strong. But you already saw the numbers. Torque or twist test, I want to measure the load at 90-degree rotation and the maximal load. One 1.8 was the peak. Carbon fiber version. 1.9. The peak 1.9. After the break they look very similarly, and for the filling they were also very similar. Now there's an impact test to see which is tougher or more brittle material from these two, and I can calculate it from difference in potential and energy using this half kilogram hammer. ASA. 0 position. Carbon fiber ASA. For the first look they broke very similarly, but now let's analyze the pictures. This is a 0 position, and this is after breaking the ASA test object, and this is after carbon fiber version. And if I measure everything from the 0 position, I can get these distances, and using this calculation I can calculate the breaking energy. Now I was first surprised that carbon fiber is more brittle material compared to the regular ASA, but then I checked the specifications on their website and basically they have very similar results, so ASA is tougher material compared to the carbon fiber version. And now my regular creep test to measure the deformation during the constant load. 1.25 kilograms. And for more accurate measuring, I am fixing the position. 1537. 1412. So less deformation on the carbon fiber version. Now we measure them every day, but off camera. In video you can see a picture taken once a day. This is day 0 with initial deformation, day 1 after 24 hours, day 2, day 3, day 4, and after day 5 I place them in the preheated oven. Temperature was approximately 51-52 degrees Celsius, and now let's measure them. So this was day 5 before heating, and this after 1 hour on 51 degrees Celsius. And I always like to record the removing of the load. And 10 minutes later this is the deformation after removing of the load. And now my oven test when I want to record the temperature of the first deformation. The main measuring unit is the cooking thermometer. You can see its screen on the left side. The one inside the oven is accurate too, but with a small delay. And as expected, ASA started with deformation around 90 degrees Celsius. Okay, I can stop the experiment now. I will analyze the footage later, but for the feeling they are very similar now after maybe 2 minutes. But a little bit more deformation on regular ASA. I already mentioned at the beginning of the video that all test objects are printed with 0.2 mm layer height, because those solid test objects have bigger tendency to warping. But now I print several objects with 0.3 mm layer height, and this square based object has also very big tendency of warping, but they looks okay. look good, and actually this is my fourth one. So printing with 0.3mm layer height is possible without any problems or warping. This is table-like base for my workbench inside the basement. And another test printing, but this time with 0.4mm nozzle on my Pusamar Series. I use 0.6 on my test objects because that's officially recommended on their website. But 3DO told me that they regularly print with 0.4mm nozzles too, so I decided to give it a try. This is approximately 3.5 hour printings, these two pieces, and during this time I had absolutely no problems with this filament. Of course, this doesn't prove too much, because you may still have problems after, I know, maybe 10 or 20 hours of printing. I just want to show you that during these 3.5 hours I didn't have any kind of problems with this Carbon Fiber ASA. This is just a mobile phone holder for the tripod, because I hate those cheap undersized spring-powered versions. And now let's analyze the results in this Excel table, which you can download from mytechfun.com website. Let's start with the creep test. This is the raw data measured distances between these two reference surfaces. What we need is the difference between 2 days. That's why I prepared this table, and this we can see on this graph. And basically these are very small values. These are in millimeters. If there would be, I don't know, PETG, it would be 5 or 10 times bigger the scale. And basically after 1 day it stopped with deformation, and even 1 hour on 41 degrees Celsius resulted very minimal additional deformation. The tensile and the layer adhesion test. Smallest cross-section area of these objects is 4 by 4 millimeters, printed horizontally or vertically, and very similar values I got with these two filaments. And this is very good layer adhesion too. Almost 40 kilograms for the breaking on this size. The shear stress, again, good results and very similar in both cases. And now that bending test. For me, this is the most important information. Let's see first this graph. These are the deformations after 30 seconds when I place 1.25, 2.5, 5 and 10 kilograms. And if we watch only this, Carbon Fiber ASA is better. Smaller values are better, less deformation. But let's see what happens if we watch the time too. So let's say this is the deformation when I place 2.5 kilograms, the initial deformation, after 30 seconds and after 60 seconds. And as you can see, this is very good. I mean, if we had a nylon, then we have some kind of angle because it continuously deforms. But let's see this one on 10 kilograms. Yes, smaller values are better, so carbon fiber has less deformation, but look at this, it didn't stop with the creeping even after 1 minute, so it has this additional deformation, until the regular ASA had a bigger deformation, but then it stopped with deformation, or even on the 10 kilogram. So carbon fiber is good, but only on the smaller loads. And this is a torque or twist test, again very similar values here. Impact test, and here I was a little bit disappointed with the carbon fiber version, so this means the regular ASA is more tougher material. This is very good values too, but regular ASA is better in this case. And the temperature is something what I expected, so ASA starts with deformation around 90-95 degrees Celsius, and that was the case here. Carbon fiber version may be a little bit bigger temperature resistance, but only 2 or 3 degrees Celsius. Link to these results you can find in the description of the video. And for my Patreon supporters, I will add these 2 lines into that summary Excel table, so they can easily compare these materials to those I tested in earlier videos. ASA is actually my favorite material type. It has even less fumes compared to the ABS, and it is great that now we have a carbon fiber version of the ASA. Now, looking only at the mechanical properties, these two materials are very similar. Bigger difference actually I can see only on IZOD impact test, and here the regular ASA performed better. And of course bigger difference is in price, so carbon fiber version is more expensive. These are prices in euros, but for relative comparison you can see the picture. So why would we choose the carbon fiber version then? Well, I could collect only a few advantages. but very important. The carbon fiber version has less tendency to warping. It's easier for printing. Of course, we need a harder nozzle, and well, it is officially recommended with 0.6mm nozzle. Another advantage is actually the better dimensional accuracy, because it has less shrinking thanks to those carbon fibers, and this may be very important for mechanical parts. Third advantage, but I think it is not so important, that a lot of people likes that looks which these carbon fibers gives to this object. And maybe the fourth one, but they only mentioned me in email, but I couldn't see anything officially on the website, is in electricity. It has bigger resistance, I think they told me, the carbon fiber version, but I'm a little bit confused because carbon actually conduct the power electricity. So I'm not sure about this fourth advantage. That was my experience. If you have some additional experience with this carbon fiber ASA, write me through lines in the comment section. Thank you for watching and happy printing!